moving on to question 3. Illustrate and explain ETL process in data warehouse concept. Okay, so when we talk about data warehouse concept, we will have the ETL process. What is it by ETL process? E means extract, T means transform, and L means load. Okay, so what do you need to extract? You need to extract data that are coming from multiple sources. Okay, so by right, it can be your operational database. It can be from the trend database. It can be from the open database. So it can be from any kind of database. But the most important one is of course your operational database lah. This is the database that they are using daily on daily basis. So by right, you can add the other sources of the database to make the data richer. So all of this will be extracted. All of this will be extracted. So we extract all of the data. We extract all of the data, then we transform the data. We transform the data. So what do we transform? We transform the data into something meaningful. So by that, how do you transform? Maybe you can summarize the data. How do you summarize the data? You do the group function. How do you function? Maybe you can do the maximum, minimum, average, or the sum, count, and so many other group functions lah. So we summarize the data. For example, you extract 1,000 rows of data. Let's say you extract 1,000 rows of data, but after you summarize data might be only 100 rows. 100 rows of summarized data. So this 100 rows of summarized data will be loaded into our data warehouse. So this is the data warehouse. So what is being inserted inside the data warehouse is the 100 summarized row. The 100 summarized row. So not you extract 1,000, you will insert 1,000 in the data warehouse process. No. That's why we have the ETL process, which is to extract, you transform the data, and you load the data into data warehouse. So this is the process lah. So the explanation, because they ask you to explain, isn't it? So what I explained just now is what you need to write lah. So by right, for example, the data, is extracted from operational database and other sources. Okay, then the data is summarized. Is summarized, or we can say the data is clean first. So why do you need to clean data? Because not all data that you extract is correct. So then data is cleaned, okay, and summarized before it is being loaded into data warehouse. So this is the explanation that you need to do lah. So there are 3 marks for the illustration and 3 marks for the explanation. Okay, so now let's move on to question B. Study the following data warehouse schema for Blue Pink Center. So we have retailer, client, sales, staff, product. Answer the following questions. State the fact and dimension tables. So when we talk about the data warehouse, so normally if you want to see what to change the display of what do you want to represent the data in terms of the data warehouse, you need to understand what is the fact table and dimension table. Fact table is something that can be quantified. Something that can be quantified. For example, kita ada sales ke, amount ke, volume. So by right, these are all the quantifiable punya attributes lah. Okay, and the dimension is something descriptive. Something descriptive. Descriptive. So something that you can describe lah. So if you take a look, what is the fact table over here? Find the table that has the amount, sales, or volume. So if you take a look over here, we have quantity. Something like quantifiable, quantity. So by right, ada lagi tak? So if you take a look, is there any kind of something that we can calculate it over here, so no. So by right, the fact table is sales. Then how about the dimensions? Then the rest can be dimensions lah. Kan? For example, the retailer, kan we can describe client, we can describe the product, and also the staff. Kan? So this is our fact table and also the dimension tables. Okay. So now question B. Explain the suitable roulette model to represent the multidimensional data warehouse model for looping center. So by right, if you take a look, for data warehouse representation, we can have ROLAP, we can have MOLAP. ROLAP is relational OLAP, online analytical processing. OLAP means online analytical processing. Okay, we have MOLAP or we have HOLAP, hybrid OLAP. ROLAP means relational OLAP. Relational OLAPs, it can be represented in terms of star schema. Star schema can be extended to become snowflake, or it can be constellation schema or galaxy schema. How about the MOLAP, multi-dimensional OLAPs? We represent data in terms of cube, data cube. How about HOLAP? This is a combination of ROLAP plus MOLAP lah. Okay, so now the question asks you about the suitable ROLAP model. So ROLAP model that we have is only star, snowflake, or constellation. So which one? So please draft the ERD over here so that you will see. Kan, because like I said, ROLAP, it looks like ERD, but it is not ERD lah. Kan, so you can draft the ROLAP model over here. So we will know that the something that fact table is something like a bridge. So the bridge is the sales. So we have sales in the middle. Sale has client ID, so they have client. Kan, then ada apa? Staff. Kan ada staff. Then ada product. Kan product ada retailer. So if you take a look, we have, this is the fact table, dimension, another dimension. Take a look, we have dimension to dimension relationship. Okay, so by right, the suitable ROLAP model is snowflake model. Kan, because star schema, kan, star schema, they have only fact table, the rest are dimension. Star schema, we have fact table and the rest are dimension. But if you have dimension to dimension relationship, this is what we call as snowflake schema. Okay, so 2 marks snowflake schema. Why snowflake schema? Because we have dimension to dimension relationship. Okay, so they ask you the last question. They ask you to draw the ROLAP model you have suggested in 2. Okay, now so by right, this one you just need to write back in terms of snowflake schema model. And the first one we have sales. Okay, so what is inside the sales? Okay, inside sales, what do you have? Okay, just write back sales ID quantity, sales ID quantity. Then we have client, staff, product, client ID, staff ID, and product ID. Prod ID, nama dia prod ID kan product ID. The name is prod ID. Prod ID. So what do we have over here? Staff. And the one that you draft just now, staff. So what is inside staff? Inside staff we have staff ID, staff name, staff ID, staff name, staff phone, and staff address. Okay, then what else do we have? Client. Kan client. So what is inside client? Hampir sama je kan, almost the same. Client ID, client name, client phone, and client address. Okay, then what else do we have? Product. Okay, product. So what is inside product? We have prod ID, prod name, prod ID, prod name, prod price, retailer ID. got price, retailer ID, and the last one, what do we have? Retailer. Okay, so inside retailer we have ID, name, phone, city. Kan, retailer ID, retailer name, retailer phone, and retailer city. Okay, so since this is not ERD, this is a raw lab model, kan, snowflake schema. So what is the relationship? Remember, the fact table will always have many side because they holds just like a foreign key, kan. That looks like a bridge, kan. The rest is one to many relationship. How about this one? Since retailer ID is inside product, so means product has many side, retailer has one side. Kan, so you don't need to have the modality. This is not ERD. Just have cardinality is enough. Kan, one client many sales, one staff many sales, one product many sales, one retailer many product. And so then we are done with the test discussion. Okay, so I guess that's all for now. Thank you.